Hi there, welcome to edupediaworld.com. You're watching the videos on probability. So in this video, we'll discuss more examples related to probability, so which are generally seen in the examination. So again, I would like to say that you have to pay very much attention to this part of a video. So let's get started with the first example. The example says that the percentage of marks obtained by a student in a monthly unit tests are given below. So this is a marks of a student obtained by a monthly tests. Unit tests, let's say it happens in the school generally. So these are the data given. So let's say this is test 1, test 2, test 3, test 4, test 5, and this is the percentage of marks obtained. Now, based on this data, we need to find the probability that the student gets more than 70% marks in a unit test. So let's say how we can solve this data. Now, we need to find that student gets more than 70% marks. So this means it should be more than 70%. So this is 69%. So this data should not be included. So this can come, and this should not be included because it is less than 70, and this is again less than 70, and this is again, so this is included, this is included, and this is included. Now, the question comes over here. Let's say if it's given 6 tests also, and the marks obtained is 70. Now, would you include this data? It's given that student gets more than 70% marks. So it's not saying that the student gets 70 or more than 70% marks. So you have to be very careful with the definition or the words they are saying. So that's actually art or magic of probability question, right? So it's saying clearly that it's more than 70%. So it should start from 70.1 or let's say 70.05 even, right? But should not be exactly 70. You have to be very careful while solving these type of question, right? Now let's say how we can solve this question now. So we need to write first the total number of unit tests held is 5. Then we can write the number of unit tests in which the student obtained more than 70% marks is 3, right? So we can say that probability scoring more than 70% marks will be 3 upon 5. So this will come out to be 0.6. So this is, we can say that the probability that scoring more than 70% marks in a unit test by a student is 0.6%, or we can say that 60%, right? So this is how we have to solve these type of example. So let's move on to the next example. The example says that an insurance company selected 2000 drivers at random, that is without any preference of one driver over another. So they were selected independently, right? Now, in a particular city to find a relationship between age and accident. So it's a very important question. The data obtained are given in the following table. So this is a table for the age and the accidents of a different, let's say 2000 random drivers. Now we need to find the probabilities of the following events for the driver chosen at random from the city, right? So first part says that being 18 to 29 years of age and having exactly 3 accidents in a year. Then second part says that being 30 to 50 years of age and having 1 or more accidents in a year. And the last part says that having no accidents in 1 year. So let's see how we can solve these type of question, right? Now, first of all, we can say that total number of drivers is 2000. Then, so first part, we can say that the number of drivers who are 18 to 29 years of age and have exactly 3 accidents in 1 year or in a year, we can say, right? So exactly 3 accidents in a year. So this is the first part. So if you check this part, 18 to 29 and 3 accidents exactly in a year, so this will come out to be 61. So we can just say that it is equals to 61. So we can say that probability the driver is 18 to 29 years old and with exactly 3 accidents, it will be equals to 61 upon 2000. So when you solve it, it will come out to be 0.0305. So which will be approximately equals to 0.031. So this is how we can solve the question, right? So let's move on to the next part. The second part says that being 30 to 50 years of age and having 1 or more accidents in a year, right? So it should be 1 or more accidents. So this means this must be included, this must be included, this must be included, and this must be included. 1 and more. So that's the beauty, that's the definition of probability, right? Now first of all, we need to find the number of drivers who are 30 to 50 years of age and having one or more accidents in a year, right? So this will come out to be, so we need to add 125 plus 60 plus 22 plus 18, right? So when we add this will come out to be 225, right? So we can say then now the probability the driver is 30 to 50 years of age with one or more accidents. So this will come out to be 225 upon 2000. So this will come out to be 0.1125. So which will be approximately equals to 0.113. So this is how we can solve the second question, right? So let's see how we can solve the third part, which is also a last part of this question. Having no accident in a year, so it means 0 accident in a year, right? Now over here the question, this question, there is no age bar mentioned. This means this includes all age bar drivers with no accidents, right? So we need to sum up all these, right? So you have to be very careful what they are asking in a probability, right? Following a probability is very easy question if you can understand what exactly they are trying to say, right? Now, so we can say that the number of drivers having no accidents in 1 year, so it will be 440 plus 505 plus 360, right? So we need to add them all. So this will come out to be 1305. We can say that probability the drivers with no accident, so it will be equals to 1305 divided by 2000, right? So this will come out to be 0.653. So this is how we can solve the probability question when these kind of question from the following data is given, right? So let's move on to the next example. The example says that 50 seeds were selected at random from each of 5 bags of seeds, right, and were kept under standardized condition favorable to germination. After 20 days, the number of seeds which had germinated in each collection were counted and recorded as following, right? The bag is given. This is the first bag, second bag, third bag, fourth bag, fifth bag, and these are the number of seeds generated. Now, what we need to find is what is the probability of germination of more than 40 seeds in a bag, 49 seeds in a bag, more than 35 seeds in a bag. So let's see how we can solve this question now, right? Total number of bags is 5. First part is more than 40 seeds in a bag, so it should be more than 40 seeds in a bag. So this means this will come, and this will come, right? Now we cannot include this value. Why? Because it's asking more than 40, not exactly 40. You have to be very careful, right? So for the first part, we can say that number of bags in which more than 40 seeds germinated out of 50 seeds is 3, right? So we have 3 bags, 1, 2 and 3, right? So we can say that probability germination of more than 40 seeds in a bag, it will be equals to 3 upon 5. So this will be 0.6. So this is how we can solve the first part, right? Now the second part, what is the probability of 49 seeds in a bag? Now if you can see properly in the question that there is no 49 seeds in a bag, so we can say that clearly that number of bags in which 49 seeds are germinated, we can say it's 0. There is no bag with 49 seeds, so we can say its number is 0. So we can say that the probability germination of 49 seeds in a bag will be equals to 0 upon 5. So it will come out to be 0, right? Third part says that more than 35 seeds in a bag. So if you can see properly the data, in every bag there are more than 35 seeds, right? So we can say that number of seeds, or we can say or number of bags in which more than 35 seeds are germinated, it's 5. So we can say that the probability germination of 35 or larger seeds, it will be equals to 5 upon 5, which will be equals to 1, right? So now if you can see properly, the probability for this event is 0 and the probability for this event is 1. Now when the probability for this event is 0, it's known as event which can never happen. You have to be very careful, right? Why it cannot happen? Because there is no bag with 49 seeds, right? It's exactly 49 seeds, there is no bag. So this kind of event can never happen in life, right? So that's why the probability is 0. Now if you check this, right, so its probability is 1. These type of events are known as show events. Why? Because the probability is 1, it will always happen according to the given data. So these type of question will generally come on the examination, right? So in the end, I can say that thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day ahead.